Okay, I'm going to work number 31 from 6.5. Now the distance between, so I'm given these two satellite tracking stations, A and B, and then that satellite up top. I'm given two angles, and the questions may vary. So what varies in these questions is how far apart the two tracking stations are. So in the problem I'm doing right now, the two stations are 65 miles apart. So I'm going to go ahead and label that. All right, now let's look and see what they're asking for. They are asking for the distance between this tracking station A and that satellite. So if you'll notice, I've already marked it. This is my A part right here. This is the unknown. This is what I don't know. All right, they've also given me two angles. They gave me an angle on the outside of that triangle. It's not a right triangle. And they gave me another angle inside that triangle. Now, since this is on the ground and this is a horizontal, this is a straight angle or a line, that's 180 degrees, which means if this angle on the outside is 87, then this angle on the inside is 93 degrees, because 87 plus 93 is 180, all right? So now I've got two angles, and actually, since I am given that 65, the distance between A and B, and I'm given two angles, let's go ahead and find that third angle. So my third angle here is going to be, I gotta have my calculator, I guess. I don't even know where my calculator is. What did I do with it? Okay, so we've got 180 minus 93 minus 84.2. All right, so this angle, itty bitty angle up here is 2.8 degrees. All right, now I am not dealing with a right triangle, so I'm going to use the information they've given me and determine whether I'm going to use the law of sines or the law of cosines. Now notice that I've got two angles and a side. I'm looking for that side. So we are going to use the law of sines. I'm going to set up my proportion here. So I know that the sine of 2.8 degrees over the side corresponding, the side opposite of that, which is 65, is going to equal, all right, I'm going to use 84.2 because I'm looking for that side A. I labeled it side A because it was just the A part. So I've got the sine of 84.2 over A. All right, now when I cross multiply, I get A times the sine of 2.8 degrees equals 65 times the sine of 84.2 degrees. And so when I divide both sides by the sine of 2.8, right, I get my A value. I'm going to plug this in my calculator again. 65 times the sine 84.2 divided by the sine of 2.8. And I'm going to approximate this to the nearest mile, so 1324. All right, so this distance right here is 1324 miles. So we were talking about miles there. All right, so we've got our A part. Now the next part of this question asks for how high is the satellite above the ground? All right, so if you're looking for height above the ground, remember that's going to be a straight line, straight up, a vertical line going straight up. And I'm actually going to maybe draw this over to the side so you don't get it all confused. All right, so I'm looking for from A straight up to that satellite. Well, that's forming a 90-degree angle right there. So let me draw that right triangle over here. So we've got this triangle. All right, all I did was take this triangle right here, this little bitty triangle. Let me color it so you can see it. This triangle right here, it's a right triangle. I drew a vertical line from A up to that satellite. All right, so this is what I'm talking about. I'm looking at, and I just blew it up so you can see it. right, so I'm looking for this distance. All right, that's what it's asking for. Well, I already found this distance, right? That's what I found in the A part. That's 1324. And what else do I have? Well, I don't need anything else because I know that that angle was 87 degrees, right? And you think about 87, this is my theta. This is actually going way back to what we did at the very beginning of the course when we solved right triangles. So I've got my opposite and I've got my hypotenuse. So I'm going to use my sine ratio. So the sine of 87 degrees is going to equal the opposite, which is B, over my hypotenuse, which I'd already found in part A, which means B is going to be approximately sine of 87 degrees times 1324, and it doesn't matter what order you write that in. And when I put that in my calculator, let me go ahead and put that in my calculator, I get the sine of 87 times 1324, and we're talking about 1322 miles. So it's just a couple miles. It's just a couple miles shorter, but that's how you find it.